This week on the Computer Chronicles, the final part of our series on high-tech in Singapore. We'll take you to the Institute for Communications Research to see the latest in mobile computing devices and new smart toys. We'll visit a digital media design center where college students are developing new computer games. This is the Philips Innovation Campus in Singapore, where they're designing the new recordable DVD decks and a new generation internet radio. We'll show you how one Singapore startup scored big with a new media entertainment series for children. And we'll visit Creative Technology to show you their hottest new product, Chronicles. The conclusion of our series on high-tech in Singapore, coming up next on the Computer Chronicles. Computer Chronicles is brought to you by the Oracle Small Business Suite, one completely integrated application that helps make it easier to run your business, including accounting, sales and service, your web presence, and more. Additional funding is provided by PC to PC, the online migration service from PC First, moving files, applications, and preferences from your old computer to your new one.
For any country or region to become a world-class leader in technology, it needs world-class universities and research centers, an educational system that can produce the people talent, which is the key requirement for any successful technology company. And that is all part of the plan for the high-tech future here in Singapore.
One of the many new educational research centers here in Singapore is the Institute for Communications Research, ICR. This institute specializes in cutting-edge research on optical technology, second-generation internet, and wireless devices. This is the Delphi Pad, designed as a portable computer, an electronic textbook, and a terminal for an internet telephony system using the new 3G technology. The Delphi Pad was developed in association with Ericsson. The Delphi Pad uses a new internet-based telephony standard called SIP, or Session Initiation Protocol, which lets you actually program the telephone, enabling it to do intelligent communications functions. This version of the Delphi Pad uses 802.11 network technology and Bluetooth, so it is totally wireless. The Institute is also working with RFID, radio frequency identification technology, that lets you embed electronic tags in objects without requiring a source of power.
When we try to develop read from a distance of 3 meters, clearly the most important breakthrough that we needed was to be able to convert the RF energy that is transmitted from the reader into power to power the tag from a very large distance. So we developed a very, very efficient technique to convert RF energy into basically power.
The other breakthrough here at the Institute for Communications Research was extending the range of existing RFID technology from a few inches to several meters.
In our technology, we can detect the tag up to a range of 3 meters. We can read as well as write IDs on the tag at the same range. And we can do it all without a battery on board, which is something we don't think is easy to achieve. Yeah.
The researchers here at ICR are working on several interesting applications for their new generation of RFID chips. This is a project to create so-called smart packaging, so that boxes you might find on a store shelf know what they are and can register themselves on an inventory database. Even the security controls on this conveyor belt system are based on RFID. A chip inside the operator's watch identifies him and authorizes him to operate the system. There are also fun applications for RFID technology. This is a smart playset for children. Each small animal doll has an RFID chip embedded in it that the big toy can read. It can then make the appropriate sound of the animal and tell the child what kind of animal it is.
This is a duck.
The researchers here are also working on next-generation cell phone technology, trying to perfect the new 3G standard.
The 3G technology is, although there is a world standard, is far from completely developed for commercial deployment. I think you must have read that there are still many problems associated with handsets and so on. So we continue to try and develop new algorithms for the handsets. We try to develop new techniques, new ways to reduce the power consumption, to perhaps make the terminal smaller, cheaper, and so on.
One of the 3G projects involves something called the smart antenna that can increase speed and bandwidth, thus enabling improved data communications for handheld devices like cell phones and PDAs. The researchers are demonstrating a smart antenna which uses an array of individual antennas and uses intelligent signal processing to dynamically switch to exactly the right combination of antennas to optimize the signal quality. You can see the greatly reduced bit error rate in the top graph that shows the signal quality after switching to the smart antenna. The bottom graph shows the high bit error rate using a standard antenna. ICR is also working on the next generation internet using technology called QoS, or quality of service. This is a smart packet switching system that can identify the kind of packet being sent over the network. It then prioritizes the packets based on the service package purchased by the user or the nature of the packets. For example, giving video packets a higher priority than data packets. In this demonstration, this web-based video conference using current internet technology has a slow frame rate and chunky-looking pictures. After the QoS technology is inserted, you see a 4x improvement in speed and picture quality. Part of Singapore's emphasis on high-tech training includes developing the skills to be creative with technology. This is Nanyang Polytechnic, a school known for its program in digital media design. Students here are working on a variety of projects, many of which end up as commercial products. This is an educational role-playing game created in Macromedia Director and Shockwave, designed to teach students about the culture of Malaysia. This robot character for another educational game is being developed using 3D Studio Max. These students are working with Adobe Premiere to develop this animated clip for teaching good driving habits. This strategy game is being developed on the Red Alert 2 engine and is designed to teach students about the Japanese invasion of Singapore during the Second World War. This first-person shooter uses the Half-Life engine and is about a terrorist attack on a Singapore power plant. It's being used to explain the need for military service and national self-defense. The students here are doing cutting-edge work, here using a programming language called WML to design a cell phone-based game called Orange Gum, which uses SMS messages in a kind of interactive soap opera. One of the biggest R&D centers here in Singapore is the Philips Innovation Campus, run by the Dutch electronics giant. They used to design and manufacture analog appliances here, but now they are working on the next generation of smart television sets and DVD devices.
In recent years, we are shifting very quickly into the digital world. So we focus in the digital technologies on storage, which is holding data, content, music, in tape and disc, and more on disc because that is more digital. We focus on display. Behind me in the background, you see a huge lab of 200 people working on display. Display in the digital world, as well as we focus on connectivities, which links the products together, wired and wireless way.
Philips is developing its next generation of recordable DVD drives here, due out later this year, and scheduled to be priced at under $700.
But one of the cutting-edge technology that we want to bring to the market and proliferate to the consumers in the near term is to bring digital recording on a disc. This will allow consumers to